Okay. Yeah, so you can go and do that is the manual part, okay, and see if we will get the same values which we will get when using the Excel inbuilt function, okay. Yeah, so as I have told you, you can now divide that is this formula into parts. Like you can see the first one, we've computed the standard deviation from now this data, okay. Then you can go to the 2 pi. Of course, we have a pi formula or a pi function in Excel, so you can find the pi value and then multiply by 2. So basically you can see if we do a pi value, it will give us that is the usual pi value, that is 22 over what, 22 over 7, which is equal to 22 divided by 7. Okay, when you do that, you can see we are getting almost the same what, the same value when using what, when using the that is the Excel function. Okay, then after that, since you have that value, you can multiply it by 2 to make it that is 2 pi. Then do a square root. We have a square root function in Excel. You can now do the square root function of the first formula part. Then for the second part, as I had said, you can now also divide it into what? Into different components. Like you already have the x values, you also have the population mean, then divide by the standard deviation for the population mean, and then you can do square root of all those values. Okay, you can square all those values, then multiply by what? Multiply by a half. The value which you will get, you can now find the exponent negative of that value. That is a negative exponent of that value. Okay. With that, you will multiply with the value which we've gotten on the first formula part. Then you will be able to get what? You'll be able to get the probabilities, all the probability of your of what, of your value. So what we need now is to do a real life or a real world example, and we can maybe Google some real life examples in what, which use normal distribution. Remember, I gave you some examples when we were doing the theory. We talked about the height of maybe of hand, the size of the shoe, also the blood pressure. Okay, they tend to follow what, a normal distribution. Okay. Yes, and so let's try and check some examples which maybe we can use here. So you can see we have the height, okay? So meaning that is majorly the height data is normally distributed. Why? Because we will have short people, we'll have also that is people with average, that is we will have few people with who are extreme short. Then we'll also have majority of people having what, having average height. And then we'll also have extreme what, extreme tall people. Like for example, the height of people is an example of normal distribution. Why? Because most of the people in specific population are of average height. The number of people taller and shorter than the average people are almost equal, and a very small number of people are extremely tall or extremely what, or extremely short. Okay, so that's why you can see this, that is the behavior. Okay, you can see how the height is what, is trending, okay, or it is distributed. Like few people will have what, short, extreme short height, okay, or they will be extremely short. Then most of the people, and you can see between this point you're having very many people. Okay, you can see very many people, so many people have average height. Okay, and then also a few people will have what, will have extreme, that is they will have extreme height. Okay, yes, the same to rolling of dice. If maybe we roll, that is a fair rolling of dice, it's also a good example of normal distribution. Okay, like when you roll, that is a dice two times, we have the probability of getting, that is, one side. Okay, one side. Also the probability of tossing maybe, three times, four times, up to maybe 12 times. Then we have a tossing of a coin. That is, um, but these I can't use as that is a good example of a normal distribution. But this can be a very good example of normal distribution. Like that is the IQ of what? The IQ of a person. Like we know, that is people with the lowest IQ, we can say they have that is an IQ of 55. Okay, so we can have IQ values ranging between what? Between 55 and the highest Q 140 what? 145. Very that is a minimal number of people who have that is IQ which is greater than what? Greater than, let's say, even 100 or greater than 110. Very few people have that is IQ which is greater than what? Greater than 110. Okay, like for Barack Obama, he is said to have an IQ of 132. Okay, so that's why you can see now he falls under maybe the 2%. Okay, of people with what? With the IQ which is greater than or that is than 130. Okay, so in this scenario of increasing competition, most parents, as well as children, want to analyze the intelligent quotient level. Well, so the IQ of a particular population is normal distributed, where the IQ of the majority of the people lies in the normal range, whereas the IQ of the rest population lives in what? A deviated range. Okay, so in fact, in our example, we'll use that is the IQ range, and see maybe in a population, if we collect the IQ of people, we can now see how they are what? They are normally that is distributed. Then we have technical stock market. That is, these are the number of stocks. Of course, in terms of prices, the way prices raise and also that is fall. Okay, so if we collect now that is the rise and falls and try to distribute them maybe over a period of time, then we can get what? We can get maybe that is a distribution out of it. Then also the blood pressure. Okay, we also have now the blood pressure, and for the blood pressure also follows, and that is a normal distribution. Okay, let's say maybe blood pressure of people, or that is people with blood pressure between 60 to 130. Okay, definitely majority will be having 100 to 1 115 or 120. Okay, majority of people will lie there, meaning within that range is where we have what? The normal, that is the normal range. Also shoe size, definitely birth weight and very many more. And then we also have students average report, or maybe students cut scores. Okay. Yes. All right. Good. Now I want us to start the practical part of it. And in this case, I want us to generate maybe some values. Like if we are going now with the value of maybe scores, let's go with the cut scores. Okay. And let's assume the cut score, or let's go even with the final exam. Okay. So the final exam, we can say maybe in a class, that is the person who that is scored less marks. Okay. Scored maybe 20, or maybe scored 30. Okay. But we still have some people with what? Some people with that is 31, with us also people with what? 50, 51, 60, 61. Okay. Yeah, so I want us maybe to generate such a data. So with that, we can decide maybe which step we need. Like the step we need to increase our what? Our, that is our data. So we can go maybe by a 5, okay, or by a 1. But let's start with a step of 5, okay. So with the step of 5, we are going to say it will be equal to this, okay, plus what? Maybe plus 5. Okay. So if we go that is by plus 5, then you can what? You can now drag maybe your values. Yes, someone has a question. Yes, Kwamboka.
Yes, yes. Okay, you see the step of five. What do you mean?
Like we are increasing, that is our values by 5.
Okay.
Yes. S- So if we are increasing our values by 5, this is how we can do. Okay, we can do this. We can say now it will be equal to the initial value, then we plus by what? We plus 5. Okay, so if we had 5, we will only need to come here and drag. Okay, you will see now your values are increasing by what? By 5. Okay, if you want to step it maybe by 2, you can as well change it to 2, and you can see now your data, that is your data here. And then once you drag, you'll see that your data is increasing by what? Your data is increasing by 2. Okay, what if maybe we can work with an increment of 2, because it will give us at least a big bracket of data points. Okay, so as I had said, you can go and do the practical using the manual way. In case you find any challenge, please don't hesitate to do what? To reach out to me. Okay. Yes. So even if it's a WhatsApp text, I will maybe I will reply back with a solution. Okay. So after that, now we need the probability mass function. Okay, the probabilities which you will get, that is when you manually calculate this. Okay, but for my case, I'm going to use that is I'm going to use um, a what? Let's say the inbuilt the Excel inbuilt function. So with the Excel inbuilt function, we are going to use the that is a function known as normal distribution. Okay, that is normal dist. Okay, so we have normal distribution, and you can see under normal distribution, it returns the normal distribution for the specified mean, okay, and standard deviation. Okay, so if you input that formula, you can see it will need what? The formula will need some calculations. Okay, the formula will need some calculations. Like for example, we will need the value of x, of course, which we have it. We'll need the value of mean, which we can compute. The mean will compute. We'll just take the, that is the sample mean, meaning it's the mean of what? Of this data. And remember, this data can be also a population. It can be a population. Why? Let's assume maybe in a class we have a total of 30 students. Okay, so if we are doing the mark, that is the distribution of all those, or we are doing an average of all those, that is 30 students, then that will be what? Will be a population, because that is the population of what? Of that class. Okay, but maybe if we were to get like a certain percentage of that class, then that would be what? That would change to what we call sample data. Okay, so we'll need this value. So we'll need mean, standard deviation. So with that, let me clear that. Let's assume this is a population. Okay, let's assume this is a population. Let's assume this is a population. So with the population, now we want to calculate the mean. So the mean will be equal to average. Okay, that is the symbol average. Then you'll get the total what? That is the average of the total values which you have. And we have a mean of 18. Okay, then we need the variance. So the variance will be that is the variance of population, because we are working with this as what? As our population. So with that, we are going to compute that as a population. Okay, then we've calculated the mean. Okay, so for the standard deviation, we can use the inbuilt function, or we can say it is square root of what? Square root of the variance. Okay, so this is the standard deviation. We can also use the inbuilt standard deviation function, which is stdev, but what? For population. Okay, so with that, you'll just that is highlight your values, and you are going to get the same that is the same value as we computed using that is the variance. Okay, all right, good. Now at least we've even referenced this. So in case maybe we want to change the variable here, maybe to 20, we don't need to recalculate. Just a minute. Why is it not changing? Or it means we are having the same, that is the same mean. Just a minute, just to reconfirm. Yes, we will still remain with the same, because we are varying constantly. We are varying it constantly. Okay. But in case maybe we change like this, 26, okay, to 40, definitely the values they will change here. Okay. Because we've created what? That is a big gap. Okay. But if we only change this but maintain what? Let's say like 60, and maintain the step. Okay, it will remain that is the mean, and also the standard deviation will remain what? Will remain the same. Good. Now let's calculate. Now we have the mean, we have the standard deviation. We can calculate probability mass function. So with that, we are going to say equal to Poisson distribution. Okay, then we need the x value. Here it's the x value. Then we need the mean. So this will be our mean, and then we'll have to reference that cell, meaning we are going to lock that cell with what? With our dollar signs, because we will be referencing. Even if I drag this formula up to this point, it should reference what? It should reference this point. Maybe I can decide not to reference, so that you may see what will happen if I don't reference. Then what else? I have that is I have the x. Okay. No, I'm sorry. You guys, you couldn't. It means you are not concentrating.
It's normal distribution.
Yes, we are working with the normal distribution, and I'm talking of Poisson. I've done a Poisson distribution. You can correct me. Hey, you people, no change even after the yesterday's talk. Anyway, that's okay. So we have the normal distribution. It will give us now the variables which we need to we need to enter. Okay, then we need the value of x, that is the x. Then we need the mean, so comma the mean, and then comma the standard deviation. Okay, all right, then I will close and enter. We have a few arguments, so meaning I have to choose what? I have to choose if I want cumulative distribution or probability mass function, and I explained the difference between the two yesterday. So I'm going to go with the probability mass function because I want the individual probabilities, and this is the probability. Okay, let me try to drag, you'll see what will happen. So you can see once I drag, it is not giving me what? It is giving me an error. Okay, that is a number what? That is a num error. Okay, why? Because I've not referenced the mean. Okay, and also the standard deviation. So with that, I have to lock the mean. Okay, and then lock the standard deviation. Okay, lock the standard deviation that way. Okay, then after that I'm going now to drag. If I drag now, you can see my probabilities. I'm generating what? I'm generating my probabilities. Okay, let me try and check how maybe they are distributed. Okay, you can see and see how they are that is they are distributed. All right, okay, good. Now I will want us maybe to do what? To do a distribution and see how maybe this will give us a presentation in terms of what? In terms of a graph. So to do that, I'm going to highlight all this. Okay, and then go to insert. I'll do a recommended graph, maybe graph, and I will do what? I'll go with since it's a what? Since it is a normal distribution, I'll go with what? With a line graph. Okay. So, so once you since we've done using that is we did not start maybe from the what? From the smallest value possible. You can see how that is the curve is what? It's trending. Okay, you can see it's like the tail, it's on the what? On the other side. Okay, and you can see this side we are having what? We are having, it's like it's where we have what? We have the peak. Okay, what if we do this? We start with the 1. Okay, so when we start with the 1, you can see now the curve is trying to what? To build up, okay, to a normal distribution. You can see it is trying to build up. What if maybe we change the step and say we need a step of 1? Okay, what if we change the step and say we need maybe a step of 1? How will the distribution look like? It will be almost what? The same. Okay, what about when we start with what? With a 0 here. You can see whenever we are reducing this value, okay? Whenever we are reducing this value, the curve is trying now to form what? To form a normal distribution. Let's try maybe with -5. If we try with -5, you can see how the normal distribution now it's what? It's behaving, okay? Why? Because this value it's what? It's extremely small. Okay, it is extremely small. What about maybe if we go with negative what? Let's say negative 20. How will the distribution? Now you can see now the distribution has been skewed. You can see this kind of skewness. Okay. Now it is skewed to the what? To the left. Okay. Why we are having a negative skewness? Why is so? Because now you can see the value. It's what? The tail, sorry, the tail is long to the what? To the right. Maybe let's try and calculate the skewness. Okay, skew. We have a skewness. Let's try and calculate the skewness of this and see what value we'll get. So we are getting a skewness of 0. And let me expand this. Okay, I don't know why. Because it should be, what about when we say skewness over population? Because this is a population. It's still giving me a 0. Why? Maybe I will check out. Okay, so with this, maybe to balance, let me go work with what? 15. So that it may be it might start with negative 15 and what? And 15. So see if we'll now have a perfect what? A perfect distribution. Okay, we're still having not a perfect distribution. Okay, now this has gone to 20. What if we say maybe negative 18? Okay, still not good. Okay, maybe 19. So with this, maybe let me, with that, we can try to maintain this, because you can see as we are changing this value is also changing up to this point. Okay, what if maybe we are maintaining this value? Let me say we have 18. Okay, there as a value, and just drag it down so that I may remove the formula, which will make it what? Which will make it look like, which will make it static, meaning it won't change. So let me change the range here. So we've extended up to cell 47. So this is going up to cell 47. Okay, then this is also going to 47. Okay, then we have the square root of this, and then we also have to extend this. You have to extend this. So select the data again. I will edit and I'll change here. Here it's going up to 45. So I'll go up to 47 here. 47. Okay, then now edit the data. Maybe let me edit the range up to, what have I done? Let me cancel that. So I need maybe to move. Oh shit. Let me just redo again. Let me just redo again the graph again. Yeah, so guys, if maybe you are not concentrating, maybe you are busy cooking somewhere, okay? I might not share the recording. I might not share that is today's recording. Okay. Yes. So we have this. What if maybe we extend? Let's try. I'm trying to check the best that is data, which will give me that is a complete normal distribution. Okay, which will give me a complete normal distribution. Let me try this. Okay. Okay, it's going down, but now, okay, it's going down. Let's try and see. Maybe the point. Oh, nice. It is giving now, trying to give me the best. So you can see as maybe we are increasing the what? The range between our, remember the range we said it is the difference between the smallest and the maximum and the minimum. Okay, so the greater or the that is the big the average, okay, the better the normal distribution we are getting. Okay, that's what we can conclude, that maybe we've tried to get what something new, like when you are increasing the range of the what, when you are trying to increase the range of the data set, okay, or the step, if I to say, but not the step, but the range. Let me call it the range, not to confuse. The range of the data, the more we are getting what? The more we are getting a better normal distribution. Okay? Then, as we decrease, maybe, or as we reduce, let's try to reduce. When we reduce, let me redo, that is the graph once again. When we reduce, you can see now the what, the distribution now tends to be what, to be skewed. Okay, the distribution tends to be skewed. That is for a normal distribution. If maybe we change this and start it maybe to 1, then the data will be now like this, skewed to the what? Skewed to the right. Okay, the data will be skewed to the right, and this is how that is now the tail will change. Okay, remember us talking about the right skewness and the left skewness. Okay, so whenever your data is moving more to the what, to the positive, okay, from the what, from the first value, then your data will be what, will be skewed to the right. Or whenever maybe that is our data, it's going down, okay, then our distribution will be what, will be now skewed to the what, to the left. Okay, yes, so that's how we can do now the probabilities. So the main idea it's here, it's to get the concept on how you can calculate now the probabilities using the Excel inbuilt function, and also using the manual way. So go and try the manual way. Okay, you can generate maybe your data if you want to do so. You can generate maybe your sample data. Maybe you can decide you will go with height data, you are going to go with blood pressure data, you are going to go through with and another that is kind of data, okay, which follows a normal distribution. You can even choose that is a work that is data which is related